if we are given x's here, then it is respect to x. If we're given y's, then it's respect to y. If it doesn't say, make the assumption that if it doesn't say and they're giving us the x values, then it's respect to that variable. So the first thing we always have to do is find y prime, and we talked about this before from yesterday. I'm just going to go through this again really fast. So this is x squared, and then this is going to give me a negative, and it's going to give me 4 over 4x, the quantity squared. And that's because what I have is I have 1 over 4x is the same thing as 4x raised to the negative 1. So when I do the derivative of that, the negative will come down out front, and then I'll drop a power, so that's why it's squared. And then of course I do the derivative of the inside by the chain rule, which gives me that. Okay, now I'm just going to go ahead and just rewrite this as x squared minus 4 over 16x squared, which we can see that these will cancel, leaving me x squared minus 1 over 4x squared. And then I'm going to go ahead and find a common denominator and just rewrite this as 4x to the 4th minus 1 over 4x squared. The only reason I'm doing that is because in a moment when I do the square root of this and I square it, it's just going to make my life a little bit easier. So now I'm going to do the integration from 1 to 3 of the square root of 1 plus, it's 4x to the 4th minus 1 over 4x squared, the quantity squared, dx, so dx. And then what I'm going to do is I'm going to go ahead and square the denominator, but I'm not going to do anything with the numerator yet. So 1 to 3 of the square root of 1 plus 4x squared minus 1, the quantity squared, over the denominator. I'm going to go ahead and square that denominator, and so I'm going to get 16x to the 4th, and this is dx. So now what I'm going to do is I'm going to go ahead and square the numerator. I didn't want to, but I'm going to kind of have to. So 1 to 3. And I'm going to have to make it a single fraction as well. So the square root of, I'm going to take and multiply this top and bottom by 16x to the 4th, 16x to the 4th. And so I'm going to get 16x to the 4th plus, and I'm going to go ahead and distribute out. Remember, when I have a minus b, the quantity squared, perfect square trinomial is a squared minus 2ab plus b squared. So this is going to give me 16x to the 4th minus 8x squared plus 1 all over 16x to the 4th dx. So then this ends up becoming this integral from 1 to 3 of the square root of 32 x to the 4th minus 8x squared plus 1 all over 16x to the 4th. And then, let me see, 16x to the 4th. All right, so then, let me see. Oh, that's where it is. Let me go back to here. I dropped my power, so these are going to change slightly. So I dropped my power. Don't be dropping your power down. So this is 4x to the 4th minus 1, so that should be to the 4th right there. That gives me 16x to the 8th minus 8x to the 4th. So once we do that, okay, so then once we do that, then what we have is we're going to combine up like terms, and I'm going to get 16x to the 8th plus 8x to the 4th plus 1 divided by 16x to the 4th dx. And then what ends up happening is that this, believe it or not, is a perfect square trinomial, so it's going to factor. So from 1 to 3, and I factor the numerator into 4x squared plus 1 the quantity squared over 16x to the 4th dx. Now I can take the square root of the numerator and the denominator, and so I get 1 to 3. The square root of 4x squared x to the 4th, man, I want to drop that power. 4x to the 4th plus 1 the quantity squared is going to give me 4x to the 4th plus 1. In the denominator, I'm going to take the square root of 16, which is 4, and I'm going to take the square root of x to the 4th, which is x squared dx. And then from there, I can just go ahead and put the 4x squared underneath each term. So what I'm doing is I'm doing 4x squared, x to the 4th. I keep wanting to drop that. 4x squared plus 1 over 4x squared. And so down here, I'm just going to get x squared plus, now remember that this is the same thing as 4x squared raised to the negative 1. So let me, why am I doing that? Okay, let me do this. Negative 1. Or equivalently, I can write it as 1/4 x raised to the negative 2. So I'm going to write this as 1/4 x raised to the negative 2 dx, and then I can just integrate like before. Is there any questions on this one? It's the algebra that's going to slay us if nothing else. It's not necessarily the integration, it's not necessarily the derivative out of the gate. I think it's going to be the algebra that slays us on this. Any questions on this? Go back to surface area, which is where we ended yesterday. So when we're looking at the surface area, so here's my surface area, and what it is it's the arc length of my curve that has been rotated. So when we're talking about this surface area, we're doing is we're finding the lateral surface area. We're not finding the total surface area. So we're not finding the area of these end pieces. We can, but we're not for this. To find the area of these end pieces, then all we have to do is find the area of what it would be at, say, this being B, and you'd have to find the area of this when this, say this is being A. And so those two end pieces, unless it's stated otherwise, will be circular, where the point is B comma F of B and A comma F of A. And then that F of A and the F of B, those Y values, are your radii if we're rotating in this direction. And so basically you'll just find the area of those two circles and add it to the total, or add it to what we had for the lateral surface area. But more often than not, it's not going to be asking for the total surface area. As engineers, as you move out, you may be asked for the total surface area, but in this case, we're just looking for the lateral. So if we are taking our arc length, and we are rotating at about the x-axis, then here's the formula that we use. So it is 2 pi r. That's what that represents right there. That represents 2 pi r. This is 2 pi r. And then this represents the lateral surface area. The 2 pi r is your each rotation. And then if you are doing it with respect to y, it's still going to be 2 pi r. And now we're just doing it with respect to y. Where a and b are the x values, and the c and d are the y values. So notice we still need, on our formula, we still need the lateral surface area. So our total, or not our arc length. So this is our arc length. And it's still part of our equation for the lateral surface area or surface area. So we still need the arc length, and then we just need to revolve it. So that's why it's the 2 pi r here, and then the 2 pi r. Okay, so if we are asked to, let me move this up. If we are asked to find the lateral surface area, I'm going to go ahead and do this one first, and then we're going to do the other ones. So we're going to revolve around the x-axis. So we have this revolution about the x-axis, and because or y-axis, here's our shape. Because we're revolving around, actually my y or my x-axis is further down. If we're asked to revolve around the y-axis, then I have to get everything in terms of y. So what I have is y is equal to x squared. So that means that the square root of y is equal to x. And that's because we're revolving around the y-axis. If I'm revolving around the y-axis, then we'll have to do everything with respect to y. And that also tells me that this is my lower limit of integration, and this 9 is the upper limit of my integration. Because I still need to find my lateral surface area, I'm still going to need to do the derivative here. So I'm going to do the derivative, and I'm going to rewrite this as y raised to the 1/2 is equal to x. That way I get 1/2 y raised to the negative 1/2 is equal to x. So in other words, I have 1 over 2 the square root of y is equal to x. Now remember that we are doing it with respect to y. So my limits of integration, I'm going to start with 1 and I'm going to end at 9 because it's with respect to y, because I'm rotating around the y-axis. Since I'm rotating around the y-axis, then I have to have everything with respect to y. So I have 2x. My function with respect to y is the square root of y. And then I'm going to multiply it by the square root of 1 plus 1 over my derivative, so 1 over 2y, the square root of y, the quantity squared, dy. So I'm going to stop at this point and ask you, what kind of questions do you have for me? The question is, why is my derivative squared? Well, my derivative squared, this part right here, the part that's highlighted in green, that is the arc length, and in the arc length it was squared. The derivative is always squared in the arc length. So when you're making your notes for the quiz or your homework or when you're preparing for the test, then you're going to write down this surface area, and then you're going to make a note to yourself that this is the arc length. So it's the arc length, and then you're going to multiply it by 2 pi r, which r is the radius, which is whatever the y value is, so, or in this case, the x value. So that's why that is, this part is squared, is because it's part of the arc length. Okay. Good question. Good question. Anything else that you have on this? Anything at all? Okay. So let's go ahead and finish this off. And again, it's not going to be your integration. It's not going to be your derivative. It's going to be your algebra. It's just algebra that's going to mess you up if you get messed up at all. So moving on with this, we're going to get the integration from 1 to 9 of 2 pi, the square root of y. On the inside here, I'm going to have 1 plus 1 over. Don't forget, I'm going to square the 2 and the square root, so I get 4y dy. Now, like before, I'm going to make this a single fraction. So if I make this a single fraction, I'm going to write this from 1 to 9 of 2 pi, the square root of y, the square root of. I'm going to take this one, I'm going to multiply by 4y, top and bottom, for numerator and denominator, by 4y. Remember, it is 1 over 1. And the reason we had to do with respect to y is because we're revolving around. So the question is, why are we doing this with respect to y? Well, the reason that we are doing this with respect to y is because it tells us we're revolving around the y-axis. So it's going to tell us we're going to revolve around which one. Like so this next example, we're going to revolve around the x-axis. So we're going to do it with respect to x. So when we're finding the solids, now we noticed when we were finding the solids of revolution, there are times when I'm doing it with respect to y, I get to stay in x. That would be the shell method. But if I am doing the disk method, then I have to do it with respect to y when I'm revolving. So the only time that I can do it with respect to x and I'm revolving around the y is when I'm doing the shell method and I'm finding the solid. So with this, because of the fact that it tells me it is the y-axis, that's why all of this stuff has to be in terms of y. Does that answer your question? Okay, cool. So then what I'm going to have is 4y plus 1 over the square root over 4y dy. Now, I'm going to use this rule that says if I have the square root of a over b, then this is the square root of a divided by the square root of b. Okay? So, again, it's not going to be your calculus is going to fail you. It's going to be your algebra if anything goes wrong. It's the square root of y. So I'm going to have the square root of 4y plus 1 over the square root of 4y, which is 2 root 2, or 2 root y, dy. So what I'm doing is the square root of 4y is the square root of 4 multiplied by the square root of y, which equals 2 the square root of y. Okay, so once I got to this point, yay, those cancel out. And then so do those. What I'm left with then is from 1 to 9 of pi, which I'm just going to pull out, the square root of 4y plus 1 dy. Now, if you're thinking u substitution, cool, that's what I'm thinking too. And so I'm going to do the u substitution. I'm going to expand that out so you all can see that. So I'm going to do u substitution here. So I'm going to say let u equal 4y plus 1. That means du is equal to 4 dy. That means I have to adjust by 1/4 du to equal dy. So this gets replaced with 1/4 du, and this gets replaced with just u. So where I am now is I have pi, and I have u raised to the 1/2, and then I need 1/4 du. Now, I have changed by the u substitution my variables. So that means either A, I'm going to write this as u sub 1 and u sub 2 as my limits, and then back substitute. I'm not a fan of that if I can just go ahead and do my values, adjust my values here. So when y is equal to 1, u is going to equal to 4 times 1 plus 1, so u is going to equal to 5. So that's my lower limit. When y is equal to 9, u is going to be equal to 36 plus 1, which is 37. So that's my upper limit. And then I don't have to go and do a back u substitution, which is my preference. But if you all want to do u1 and u2 as placeholders and then back substitute, that's totally up to you. Okay. So then what I have is I have 1/4 times pi, or in other words, pi over 4. When I integrate this u raised to the 1/2, I'm going to add 1. So I'm doing 1/2 plus 1, which gives me 3 over 2. So this will be u raised to the 3 over 2. But don't forget, I have to multiply by the reciprocal. Excuse me. So I'm going to multiply by the 2 divided by 3. So don't forget to multiply by the 2 divided by 3. This 2 will cancel with that, giving me 2. Evaluated from 5 to 37. So what I am at right now before I do the evaluation is I'm going to have pi over 6 u raised to the 3 over 2 from 5 to 37. So pi over 6, and then I have 37 raised to the 3 over 2 minus pi over 6, 5 raised to the 3 over 2. Now, when I have a raised to the 3 over 2, then what this is equal to is a raised to the 1 plus 1/2, which is a to the 1, a to the square root, if you want to do it that way. So this is going to be equal to, I'm just going to pull the pi over 6 out, no particular reason, 37 root 37 minus 5 root 5. That's your exact answer, but you can also put that in your calculator and get an approximate. If it wants the exact answer, then here's my exact answer. And if it doesn't ask for the exact answer, I can just throw this thing in my calculator. So I'm going to go ahead and stop this. So when you find the derivative, which is a nice number because we don't have to worry about x, so that when we plug it into the square root of 1 plus the derivative squared, I'm just going to get the square root of 50, which is nice. That means it's just a constant, and I can totally ignore it when I do the integration. It's just going to be a constant multiplier. But if I take a look at the graph, this is the line y equals 7x. It's going to go through the origin. It's going to have a 7, 1 slope. So this is what it looks like. Now, if I try to integrate this without worrying about the fact it did cross the x-axis, then when I do the integration, I'm going to get 0. It's going to cross itself out because of the symmetry. And whatever is below the x-axis equals whatever is above the x-axis. So option A is you go ahead and you do the integration with -1 to 0 and 0 to 1. That will work, so you do 2 integrations. Or because of the fact that this side is symmetric, so the left side is symmetric to the right side, you can just do one of the two sides. I chose the right side, going from 0 to 1 and just multiplying it by 2 because of the symmetry. And then this is a pretty straightforward integration once you get to that point. So then the integration here is I'm just going to pull out all my constants to make my life a little bit easier, except for one of the 2's. I'm going to take that 2 and leave it just simply because I see I have x. So I'm going to pull out all the rest of the constants. I'm going to pull out the 2 that's already there and the square root of 50 and the pi from 0 to 1. And then I'm going to leave that 2 and I'm going to leave that x and the dx. And the only reason I'm doing that is because I know that when I do the integral of 2x, it's going to be x squared, and I don't have to make any adjustments. That's the only reason why I left it there. No other reason. And so this is going to be equal to 2. Well, the square root of 50 is the square root of 25 multiplied by 2. So I'm just going to go ahead and, oh, and I forgot my 7. Don't forget my 7. So let me squeeze in my 7 there too. So times 7. So it's 2 multiplied by the 7 multiplied by 5 root 2 multiplied by pi of x squared evaluated from 0 to 1. That should be the square root of 2. And so what I'm going to get is I'm going to have 2 times 5, which is 35, times 2, which is 70. And so my final answer is going to be 70 root 2 times pi, evaluated when x is 1, so it's 1 squared, minus when x is 0, so that's 0 squared. So my final answer is 70 root 2 times pi. How was that? How was that one? Stop a minute. Here. So for our next example, this is where the algebra may mess us up. So the first thing I always do is find y prime, and I need to find y prime because it's part of the equation, finding the surface area. So this is going to be 1/2 by the chain rule, 4 minus x squared raised to the -1/2, multiplied by -2x. So by the chain rule, that's what that is. I'm just going to rewrite this as y prime is equal to -x, 4 minus x squared raised to the -1/2. So all I did there was just rearrange it, and it is the chain rule. Okay, so let's just finish this one off. And I have 2 more examples, and what I'm probably going to do is I'm going to go ahead and add these 2 more examples after class so that you'll have all the examples ready and available for when you're doing your homework. And then, of course, I got an application one I'll do last. So I'm going to finish this one off, or at least the setup, and then I'll finish the rest of it. So on this, I'm just going to erase this here because I need the space. So then what I'm going to have to do is I'm going to do the integration from 0 to 2 pi times my function, which is the square root of 4 minus x squared, multiplied by the square root of 1 plus my derivative. I'm going to write this as -x over the square root of 4 minus x squared, the quantity squared, dx. Okay, so just like before, this is going to be equal to, from 0 to 2 of 2 pi, the square root of 4 minus x squared. This is going to be equal to 1 plus x over 4 minus x squared dx. I'm going to see a theme here. I'm going to multiply this by 4 minus x in the numerator and 4 minus x squared in the denominator. So this is equal to, from 0 to 2 of 2 pi, the square root of 4 minus x squared. And then this is going to be equal to the square root of 4 minus x squared. Oh, don't forget that should be squared because I had to square the numerator and the denominator. Plus x squared over 4 minus x squared dx. And then what I'm going to do is I'm going to use the rule that if I have the square root of a over b, this is equal to the square root of a over the square root of b. So this is equal to, from 0 to 2 of 2 pi, the square root of 4 minus x squared. And then the numerator, notice my x squareds cancel themselves out, so I just get 4. In my denominator, I'm going to get the square root of 4 minus x squared dx. So we get a really nice cancellation there, which is sweet, because then what we get is the integral from 0 to 2 of 2 pi. The square root of 4 is 2 dx. So even though this thing looked terribly, terribly ugly, it really isn't too bad, because what I'm really asked to do is to integrate from 0 to 2 of 4 pi dx. And we like this because it's going to be 4 pi x, don't forget that pi, 4 pi x from 0 to 2, which means it's just going to be 8 pi. So even though it looked really nasty to begin with, that derivative was not pretty, that it actually cleans up fairly well with the algebra. Is there any questions on this one? So I'm going to expand out so you can see all of it in its entirety. Is there any questions on this one? So the question is, why is it not a negative? When you're doing the integration, it's always f of b minus f of a. So it's always your upper limit minus your lower limit.
Okay, that makes a lot of sense.
Okay.
It would be 8 minus 0.
Yep. I don't know why that does that sometimes. It does that green screen. Anything else? Oh, so the question that David had was, why did I square the x but not the 4? So I think what you're asking about is way back here, maybe? Way here? Is that what you're asking for? Is right here? Is this where I've got this? Okay. So when I am squaring the numerator, I have negative x squared, which will become x squared. But when I'm squaring the denominator, I'm squaring a square root. So when I square a square root, whatever's underneath the radican, 4 minus x squared comes out. So that's how come the x squared is on the numerator. Now this was x squared in the denominator already, because that was part of my derivative, and then the 4 minus x. So that's why this is 4 minus x squared. Any other questions you have for me on this? Okay, let's take a look at D. Now, because of the fact that I am asked to find the area, or the surface area about the y-axis, I need to make this x equals 0 and x equals 3, and this as well, into terms of y. So I'm differentiating with respect to y, or integrating with respect to y. So that means I need to change this into its upper and lower limit with respect to y. So first thing I'm going to do is say y minus 1 is equal to x. So now I have it in a function in terms of y, and I'll need that. And then when x is equal to 0, so when x is equal to 0, y is equal to 0 plus 1. So my lower limit is 1. When x is equal to 3, y is equal to 3 plus 1. So my upper limit is 4. So I'll need that for my limits of integration. So I know when I do the integration, it's going to go from 1 to 4. I had to do this again. The reason I'm doing this is because it is with respect to the y-axis in terms of the rotation. So this 0 to 3 had to be what the y values are from 1 to 4. So there's the 1 to 4. I'm going to come over here and I'm going to go ahead and do my derivative. So dy is equal to just dx. Or in other words, 1 is equal to dx. dy. So we like that when that happens. So this is going to be 2 pi, and then my function, or my radius, which is y minus 1, multiplied by the square root of 1 plus my derivative squared, dy. So this is equal to 1 to 4 of 2 pi y minus 1, the square root of 2 dy. And what I'm going to do is I'm going to go ahead and pull out the square root of 2 and also the pi. So I have the square root of 2 times pi, 1 to 4, and then I'm going to distribute the 2 through, so 2y minus 2 dy. So again, what I did was I factored out the 2x, or square root of 2, and I factored out the pi, and then I distributed this 2 onto the y and the 1. So then this is going to be equal to 2 pi. I'm going to do the integration, so I get y squared minus 2y, evaluated from 1 to 4. And so I'm going to get 2 pi as the multiplier. I'm going to put in 4, so I get 4 squared minus 2 times 4, minus 1 squared minus 2 times 1. So this is going to give me 2 pi, and then I'm going to have 16. This is going to be 16 minus 8, which is just 8. And this is going to be 1 minus 2, which is just negative 1. 1 minus a negative 1 becomes a positive 1. And so my final, oh, and I forgot the square, that is the square root of 2, excuse me. That is the square root of 2. Square root of 2. So my final answer is 9 pi, the square root of 2. And that's my final answer. Or 9 squared root of 2 pi, it doesn't matter. So that's how you're going to do that one. Now let's take a look at this one. Now again, we've got to pay attention to the fact that I am asked to revolve about the y-axis. So I'm going to have to figure out the equivalent y values, just like I did up above, for these to get my limits of integration. And I'm going to have to solve this for y. So let's go ahead and find my limits of integration. When x is equal to 0, y is equal to 1/2. When x is equal to 1, y is equal to 1/2 plus 1/2, which is just 1. So now I've got my limits. And then I'm going to take this and solve for x. So the first thing I'm going to do is multiply everything by 2. So 2y is equal to x squared plus 1. So 2y minus 1 is equal to x squared. And so I have the square root of 2y minus 1 is equal to x. I should normally put the plus and minus on it, but we are talking about the first quadrant because when x equals 0 to 1. So I'm talking about the first quadrant, so I'm going to take the positive of it. Now I know what my limits are going to be. My limits of integration are going to go from 1/2 to 1, but I need to find the derivative of this. So I'm going to find the derivative, x prime. X prime is going to be 1/2 2y minus 1 raised to the negative 1/2 multiplied by the inside, which is just 2. So those will cancel. So my x prime is just going to be equal to 1 over the square root of 2y minus 1. So let's go ahead and put everything in its right places. So this is going to be equal to 2 pi times my radius. My radius is the function with respect to y, so 2y minus 1. the square root of 1 plus my derivative, which was 1 over the square root of 2y minus 1, the quantity squared, dy, am I right, dx, dy. And so let's do our algebraic cleanup. So I have 1/2 to 1 of 2 pi, the square root of 2y minus 1. Now, when I square the square root, so it's going to be 1 plus, I'm going to square this 1, so I'm just going to get 1. And then I'm going to square the square root, so I get just what's underneath the radical, which is 2y minus 1 dy. All right, so then this is from 1/2 to 1 of 2 pi, the square root of 2y minus 1. I'm going to make this the same common fraction, so I'm going to multiply 2y minus 1 and then times 2y minus 1, so I can put it under the same common denominator. And so I'm going to get 2y minus 1 plus 1 all over 2y minus 1 dy. So this is going to equal to from 1/2 to 1 of 2 pi, the square root of 2y minus 1. And like before, if I have the square root of a over b, this is the square root of a over the square root of b. So then this is going to be multiplied by the square root of 2y over the square root of 2y minus 1 and times dy. And the reason this is 2y right here is because back here I have a -1 and a +1, and they will cancel each other out. So that's why I end up with just a 2y right there. And you'll also see that the square roots cancel themselves out as well, so that's pretty nice. So we're going to integrate from 1/2 to 1 of 2 pi, and then I'm just going to write this as 2y raised to the 1/2 dy. Now what I'm going to do is I'm just going to rewrite it again slightly differently. So I'm going to write this as from 1/2 to 1 of 2 pi, the square root of 2, and then y raised to the 1/2 dy, because 2 is just a coefficient, and I know that if I have the square root of 2y, I can write this as the square root of 2 multiplied by the square root of y. So that's all I'm doing. Okay, so then once we do that, then we're going to go ahead and integrate, and when we integrate, remember, we add 1 there, so 1/2 is the same thing as 3 over 2. So this is going to be equal to 2 pi the square root of 2 multiplied by the reciprocal, so 2 over 3, y raised to the 3 over 2, evaluated from 1/2 to 1. So I'm going to have 2 pi the square root of 2 times 2 divided by 3 of 1 raised to the 3 over 2 minus 1/2 raised to the 3 over 2. So just as a reminder, 1/2 raised to the 3 over 2 is the same thing as the square root of 1/2 cubed, which is the same thing as 1/2 multiplied by the square root of 1/2, which is the same thing as the square root of 2 over 4. Square root of 2 over 4. And that's because what ends up happening here is I have 1/2 multiplied by the square root of 2 over 2, if I rationalize the denominator, multiplied by the square root of 1 over 2. So this is going to give me the square root of 2 over 2 times the square root of 2 squared, which is 2, so it is square root of 2 over 4. So this is going to be equal to 2 pi square root of 2. Well, actually, let's do this as 4. Let's rewrite this as 4 the square root of 2 over 3 pi. And I have 1 minus, it'll be the square root of 2 over 4 which is going to be equal to 4 the square root of 2 over 3 pi. And then inside, I'm going to get 4 minus the square root of 2 all over 4. So then I can factor out of the 4 out of the parentheses. And so I've got 4 root 2 pi divided by 3. And then I'm going to pull out that 1/4, leaving me 4 minus root 2. Then these 4's will cancel, leaving me the square root of 2 pi divided by 3, 4 minus the square root of 2. And you don't have to leave it like that. If you wanted to way up here, if you decided, wow, that's way too much work, you can go ahead and just distribute. So you get 4 the square root of 2 over 3 pi minus, and when you distribute onto here, then you can see your 4's are going to cancel. And when your 4's cancel, when you do this 4 root 2 over 3 pi multiplied by root 2 over 4, then what'll cancel with it is your 4's. Your square roots are going to cancel, and so you're going to end up with, if you decide to distribute through and leave it as an exact, is you're going to get 2 over 3 pi if you're inclined. Doesn't matter. Either or any of these will work. I'm good. So that's the answer to that one. So now let's take a look at this one right here, which is the lampshade. So what the lampshade is on this example, it is around the x-axis, but what is happening is that this is the x-axis. So instead of putting the lampshade on its side, which would have been much easier, but then it would have not looked like a lampshade, that is the x-axis, and then this is the y-axis. This is the positive y. So in other words, it's like taking the shape, and the shape actually would have been looking like that, revolving around the x-axis, but then your lampshade would be on its side. So this is just so you know what it looks like. Now with this, you've got to have the formula. Again, your formula is going to go from a to b of 2 pi, your function with respect to x, the square root, I don't know why I keep doing that, the square root of 1 plus f prime of x squared, dx. So this is one that you really should know, integration by parts, because it does make it a lot easier. I have to figure out what my a and b is. They're giving me my y values, so I have to figure out my a and b. So when y equals 1, and I'm using y is equal to 1 over x, 1 is equal to 1 over x is equal to 1. So when y equals 1, x is 1. When y equals 2, we get 2 is equal to 1 over x. And so x is equal to 1/2. So my lower limit is 1/2, and my upper limit is 1. So this is going to be the integral from 1/2 to 1 of 2 pi of my function. My function is 1 over x. And then I'm going to multiply it by 1 plus. Now f prime, so come over here, f prime of x is going to be negative x raised to the negative 2. Because remember, when I write f of x is equal to 1/2, or 1 over x, I write this as x raised to the negative 1. That just makes my derivatives easier. So this is negative 1 over x squared dx. So this is going to be equal to 1/2 to 1 of 2 pi, 1 over x. And then inside of here, I'm going to get 1 plus 1 over x to the 4th dx. And so this is going to be equal to 1/2 to 1 of 2 pi, 1 over x. Inside, I'm going to get x to the 4th plus 1 all over x to the 4th dx. So 1/2 to 1, 2 pi, 1 over x. And then what I'm going to do is I'm going to take the square root of the numerator, separate than the denominator. And so this is going to give me the square root of x to the 4th. I wrote 2x to the 4th plus 1 all over x squared dx, which is equal to the integral from 1/2 to 1 to pi 1 over x to the 3rd, the square root of x to the 4th plus 1 dx. And then I'm just going to stop right here, because at this point, the only way this is going to work out well is if I do it by integration by parts, and that's in Chapter 3, so we're going to leave that for right now. And hopefully I'll catch any of the ones that are like this on the homework prior to you doing the homework. I'll make sure that none of the ones that you have hopefully don't have integration by parts. Other than that, 2.4 is done and dusted, and we will see you tomorrow.